Hello everybody, my name is Jalen Francis, and today I'm going to be going over a hackathon project that me, Jason Clark, and Farhan Sadiq all developed at the Berkeley AI Hackathon. And as you can see, I'm wearing my Bay Area hat to represent San Francisco. Okay, so let me tell you about our project. So our project was called DiffSense. And DiffSense is an AI-powered code change intelligence and breaking change detection tool where it turns code deployment from Russian roulette into predictable science. Okay, so here was our inspiration. So every developer has that one commit that haunts their dreams, a simple function rename that crashes the mobile app, a harmless API update that locks out millions of users, a database schema change that wipes data forever. So the inspiration for DiffSense came from watching brilliant engineering teams repeatedly fall into the same trap, invisible breaking changes. We realized that these disasters aren't random. They're predictable. So the connections between code changes and their cascading effects follow patterns that human eyes miss but AI can see. So DiffSense is basically like having a crystal ball for your code changes. It's an AI-powered platform that does the following. Predictive breaking change detection. So we analyze every code change using advanced machine learning models. We predict ripple effects across your entire code base. We provide impact severity scoring and affected user estimates. Also, we have intelligent context analysis. So we use RAG, retrieval augmented generation, to understand your code base. We leverage Claude AI for natural language explanations. We perform deep abstract syntax tree analysis and pattern detection. We maintain historical context of previous breaking changes. And then we make smart recommendations where we generate actionable suggestions to prevent disasters, provide migration strategies for necessary breaking changes. We prioritize fixes by business impact and technical risk. And so we have real-time integration where we have GitHub OAuth integration for seamless repository access. We use a RESTful API for integration with existing CI/CD pipelines. And we use vector embeddings for semantic code similarity analysis. So here's how we build it. So for our front end, we use React with Vite, Tailwind CSS for beautiful responsive UI. And for our backend, we utilize Fast API with Python for high-performance API endpoints. And we had the following AI/machine learning stack. So we use Claude AI for the natural language understanding, CodeBERT for code semantic analysis, sentence transformers for vector embeddings, and we use custom ML models for breaking change detection. For our data layer, we use SQLite for development with vector caching for embeddings. Our infrastructure consisted of layer architecture supporting future microservices migration. So some innovations we had were that we used semantic code analysis combined with the AST parsing with machine learning embeddings. We had an intelligent RAG system that was context aware for better AI responses. We did not just feed in to Claude, we selectively chose the context based on whatever questions or whatever we were using. We did predictive breaking change models where we had a custom ML pipeline trained on Git history patterns. So our deployment process, we had an AI first design philosophy from day one, extensive testing with real world repositories. Okay, so now we're going to get into actually running this thing. So there's two parts. You have the front end and the back end. And so if you clone the repo and you set the environment variables properly, following the .env example, so this will consist of putting, like for the back end, your API keys, other directories and so on, and then front end's pretty simple, just telling you where your back end is. Okay, so we're in here. To start the back end, we just run python main.py. And so right now it's currently configured to run on port 8080. And so we load all our models, we load everything, and now we can see that we're running on our local host 8080. And so the front end, this is actually running on a server that we have. So the front end is connected to the back end through port 8080 on a separate server. And so we set up port forwarding to make sure we can access it. So on the front end, once you're in there, you have to do like your npm install to actually get the packages. Yeah, once you're in there, you can now run npm run dev. And so this will go ahead and start the Vite server at localhost 5173. Okay, so now this is running on our localhost. So this can be extended to a website, but for now, you can just run it locally. So now we're in here, and so here's the homepage. We have DiffSense, where analyze your Git diffs like never before, and just a little intro, but here's where the magic happens. You can continue with GitHub. And so if I click on that, currently it's redirecting. I'm already logged in. This is using my own GitHub. but it will send you through the login if you haven't done so already. So now once I'm in here, you can go ahead and add a repository. And so you can add by URL, or you can browse your repos. And this includes public and private. So if I go in here, I'll do a simple one. So this is a project that I made previously called Shell. And this is a very simple repo. But if I go in here, it will go ahead and upload it, and it's uploading it to the backend. So if I go in here, it goes ahead and searches through it, and you can see we're hitting our backend API. So now once I'm in here, we can do a breaking change analysis. We can see a risk dashboard, which just goes ahead and this looks through, and it tells us what files we might have issues or which ones are changes. Like, see, we can look at high risk commits, and we can go ahead and go through and we can view, and there's also, we can view through the files, and we can look through the different commits and view all those. So here's the magic. So if I go through our breaking changes, we can look at recent commits or commits since a specific one, or we can select specific commits and it'll do analysis on there. So I'm going to go ahead and click this, and we're going to look at a breaking change analysis since this. So if I go ahead and analyze that, it runs pretty fast because we already have everything in there. But as you can see, we went ahead and hit our API. So it tells us what commits were analyzed. So there were no breaking changes there. But if I go through, let's go a bit further. Okay, so now we have some breaking changes. And so if we look in here, this tells us what type of breaking changes this might be. So what you can do is you can see whether or not a change you're making, whether it's intentional or not, if it might break your code base. And so it looks through. So here, as we can see in the following, we had set foreground PID. It was a C/C++ function, and it was removed. And all of these were all removed functions. And what happened here, as I think in this code base, there was a lot of refactoring going on at that time. And we can see in our risk dashboard, this commit had a lot of possible breaking changes. Okay, so now here's another cool feature. So we have all these breaking changes in a risk dashboard, but we also have a chat which can look through all your previous commits, and it uses the RAG model to interact and try to come up with human readable responses. So if we go in here, we can just say, give me a code structure overview of this entire project. And so as we can see, it's thinking. It pretty much looks through the architecture and tells us about any design patterns. But to get to some of the usefulness, you can ask very specific questions. And so the way our RAG model works is that we give our AI model, Claude in this instance, we give it specific context based on what files you're asking about. And depending on your type of question, it enters like a different mode. So one thing we can do is, so we can say, can you give me a security analysis of parser.c. So in here it says there's some critical vulnerabilities. So it tells us carefully review the code that deals with the token processing and extraction, ensure that all user provided input is properly sanitized and validated to prevent security vulnerabilities such as injection attacks. And it gives us a lot of suggestions and a security checklist of what to follow. But for the most part, it says it's classified as low risk, and so we're pretty much fine. Can you tell me about how executor.c changed over time and any other possible security vulnerabilities? Alright, so I'm going to ask, can you tell me about how executor.c has changed over time? So in this, it's doing a senior software engineer analysis. This is one of our modes of their Claude. So, okay, so it talks about what are our key entities and functionalities. So we have execute pipe, continue job, These are all very important functions in this. It talks about these functions work together. So we have code quality and maintainability, some resource management. So it does a little analysis and it says there are no major issues or risks identified. The code base appears to be well designed and maintained with a low complexity score, no apparent technical debt indicators. And then it gives us some, recommendations, and it tells us, here's what we should follow to make this a little bit better. So remember, this is our best part, is if we can say, hey, can you tell me about any breaking changes in the code base? Okay, so it gives us through. The detected breaking changes are deemed high risk due to the complete removal of critical core functionality in the built-in commands and main.c files. These changes will have a significant impact on existing users. Okay, so it goes through here. The removal of the following functions will have the most significant impact on users. So CMD help. This is a critical command that provides users with essential information. CMD exit, CMD jobs, CMD env, cleanup background processes. So it tells us, here's a migration strategy, is that you can re-implement this, go through a deprecation period, version planning, some documentation needs, and some backwards compatibility. And so also all these conversations are remembered. Everything goes into a database, including all your repositories, your users, everything that goes on. We all cache to try to keep the site as efficient as possible. We have a light mode and dark mode. Okay, so back to the overall project. So here were some technical challenges. Scale of code analysis. So analyzing entire repositories efficiently can overwhelm resources. So in this example, we use a relatively small code base, and it can do okay on medium. But when you go to very large code bases, we had to put restrictions on how much code we analyze, because we're copying over and we're looking through the blobs and everything to try to build trees of kind of like how your whole code base is structured and looks. And so with that too, we also had context window limitations where, we can only feed in so many tokens into Claude. And so this made things a little bit difficult when doing our RAG model, because we had to selectively figure out what type of context we wanted to feed in, what type of question the user is asking, and so we can feed things into it. False positive management. So sometimes when things are removed, that's okay, but we need to balance sensitivity with practical usability. And then making sure we have real-time performance, and so delivering instant feedback without sacrificing accuracy. And so currently, right now, we don't have any real-time stuff going on, but eventually that would be our goal, is if we continued on with this project, we would like to have a VS Code extension, so you don't have to actually make commits into a repository to be able to see things. Because currently what you'd have to do is make a branch and then make the commit, and then before it actually goes into prod, run our real-time difference. But if we're doing this in VS Code, if it's a VS Code extension, we can predict any breaking changes before you actually make the commit. And so you can run a little check, or even while editing. Some integration challenges were some GitHub API rate limits, cross-platform compatibility, and so we want to make sure it works throughout different development environments. So currently it's only configured for GitHub, and so this doesn't work if you have any private server repositories. So if you have your own Git server. Some security and privacy. So handling sensitive code data with enterprise-grade security. We want to make sure that we're storing your data securely, because we are storing your whole entire code base. We don't want someone to go in there and take that. Performance optimization. So we were just running this on one server on one computer. If we wanted to actually take this further, it would require a lot of scalability, a lot of different computers and hosting. Some accomplishments that we're proud of, though, was that we built a working AI system that can actually predict breaking changes. We utilized a breaking change detector to power our web app, and we fine-tuned a RAG model to smart prompt a Claude API. And Claude isn't really that important. I mean, we would have to change some of our structure and then get different API keys. But the Claude model is not that important. The important part is the RAG model and trying to selectively choose our context and feed in the right questions. Some innovation is, this is first of its kind. I haven't really seen a predictive breaking change detection that looks at different commits. For the most part, when people use AI tools, it's feeding in like one-time changes. It might look at the repository as a whole, but not how things have changed across different commits, which is important because you want to look at how things are changing. And so I think this is also a novel combination of static analysis, machine learning, and AI reasoning. And I think the UX behind the front end looks really nice, and it makes the complex AI accessible. Okay, some things that we learned were that here we had made some technical insights. So AI works best with its structure. Combining traditional static analysis with AI gives better results than pure AI. And so doing semantic vector embeddings of your code and then trying to pair that with the RAG made things a lot easier. Context is everything. The quality of our RAG system directly impacts AI accuracy. And so if our RAG system is not finding the right things, our Claude API won't be as good. Some user feedback is gold. Read real developer uses patterns can teach us what actually matters. Okay, so what's next for DiffSense? We'd like to do a VS Code extension that gives inline risk alerts and code search. We'd like to fine-tune models on commit level breaking changes. And third, this is a big part, is improve code embeddings and retrieval quality. And so again, the better our RAG is, the better outputs we get. Add context retention for multi-turn queries. So currently, every time you ask a new question, it's finding its new context. It's not kind of considering the last question you asked, which can be important if someone has follow-up questions. And then scale backend infrastructure for faster, larger repo support and also to handle multiple users. So now to conclude, the future is predictable. So DiffSense represents a fundamental shift in how we think about code changes, and instead of crossing our fingers and hoping for the best, we're moving toward a world where every change is analyzed, understood, and deployed with confidence. So we're not just preventing bugs, we're preventing disasters. The future software isn't about writing perfect code, it's about knowing exactly what your imperfect code will do before it's too late. So, welcome to the future of predictable code deployment. Welcome to DiffSense, and see you guys later.